and we're finding limits. So we look at it in terms of a number line, just looking at the x values. It would be the equivalent of saying we were looking at, this is our 1, 0, -1, 2, 3. What this means, this limit as x approaches 1 from the right. This means that we're coming in, this is our right, We're approaching in towards 1. We're approaching it. However, limits do not actually reach the number. In this case, at the very least. It is simply gets extremely close, but does not actually reach it. This little nudge right here, this little bump, that is the value 1. We are looking at the numbers right here. So this would be 1.1, 1.01, 1.001, and so on and so forth. Getting extremely close to 1, but not necessarily at 1. So how do we solve a problem like this? Generally, the easiest step would simply be using direct substitution. So if we acknowledge that the limit as x approaches 1 from the right is the same as saying these numbers, and in particular this pattern, we assume that it's something ever so slightly greater than 1. If we're all in agreement on that, we can simply put in this 1 slightly greater than into the original equation. So let's do that. We have the limit as x approaches 1 from the right of slightly greater than 1 squared minus 9 over slightly greater than 1 squared plus 2 times 1 slightly greater than minus 3. So this is our numbers. Now let's take a look at this. All we have to do is the simple math here. Bring it down, limit as x approaches 1 from the right. And slightly greater than 1 squared is going to still equal, be something ever so slightly greater than 1. Minus 9 is going to come out to -8, but ever so slightly to the right. And then we have a number slightly greater than 1 squared plus 2 times 1 slightly greater than and minus 3. So if we take a look at this, what we have here is something slightly greater than 3. So 1 plus 2 is 3, but these little positives give us something slightly greater than 3. So slightly greater than 3 minus 3. This equals -8 to the right all over a slightly positive 0. Now, from this, because it's divided by 0, we could say that the limit as x approaches 1 from the right of our f of x, well, it simply does not exist. And numbers divided by 0 are essentially going to head towards infinities, which would be unbounded behavior. Wherein it either keeps increasing or keeps decreasing. We're not entirely positive of that. But we're going to take it another step further because we know how to solve this and figure out what type of unbounded behavior it shows. So we'll look at it like this. The limit as x approaches 1 from the right of f of x is indeed equal to -8 divided by slightly positive 0. Now, if we accepted previously that slightly positive 1 is the same as saying 1.1, 1.01, and slowly getting closer to 1. Something very close to the right side of 0 would be just slightly positive number, essentially. And if we already know that anything divided by 0 is going to show an infinity, we know that this slightly positive 0 would become a positive infinity. So we have the limit as x approaches 1 from the right of f of x. And just so everyone's clear, the f of x in this case is referring to the original equation. I forgot to state that, but it's simply a given that f of x is your equation, wherein you have f of x is equal to x squared minus 9 over x squared plus 2x minus 3, because we are taking the limit of a function. Alright, now back to this. The limit as x approaches 1 from the right of f of x is equal to negative 8 divided by a positive infinity. Now, a negative number divided by a positive number is going to come out to a negative number. So what do we have here? Well, this is our true answer. The limit as x approaches 1 from the right of f of x is equal to negative infinity. And if we were to look at a graph of this, we would actually get something that looked vaguely like this right here. Approaching 1 from the right. This is our 1. This is the right side of it. It approaches negative infinity in our y values. Something essentially like that. Some sort of asymptote here for it to do that. And we could solve that algebraically if we would like to and simplify the polynomials in the original function. Regardless, our final answer is negative infinity, although we could simply leave it at limit as x approaches 1 from the right of f of x does not exist. As previously stated, you can say because of unbounded behavior, you can say because we divided by 0. The point is, technically, the limit does not exist. And that's all.